As usual, we begin with a single cylinder and it's packaged like this. In this case, we have only this component. We have the end, which is this one. That's the end rotor. And then we have the cylinder unit. So just those two components. But this second component consists of the following components. It consists of the connecting rod here as a component. Then you have the crank here as another component. Then you have the cylinder here as a component. And then the full piston now containing both. If you now look at the full piston, it contains. So if you want to look at just the piston alone, so you have this, just the piston. And then you can also take a look at the pin only. These two together constitute the full piston, which we can now see here. So, and all that is just one component again inside the component containing every other thing, which we can see here as the full single cylinder part. And then we add the end rotor to all of this to get the, so you can see now that we have two components. As before, we can also animate this motion by just take this okay. So we can animate the motion with the two components, that is the end rotor as well as the cylinder block. If you pick that home, so this is now a single pattern replication. In a single pattern replication, which we can edit this way and take a look at what we have done there, edit rectangular, and then edit rectangular pattern, we have the component we have chosen now is only a single component, only the cylinder assembly that has been chosen. The cylinder assembly contains everything except the end rotor, and then we can replicate, make 8 of them in single axis, only one in the other axis, and we make the distance between, the total distance is 912. So that is it. And the interesting thing here now is that once we finish this, we see that all the constraints, motion, and joints are captured in this. So the next thing for us to do is to now begin to apply our angular orientations. To apply the angular orientation, we pick one cylinder at this point and take a rotation. We can, is this cylinder, is this crank? So if we choose that crank in the second assembly, no, not in the second assembly, so let us go to the second assembly crank. So we take this crank and then we are going to give it a rotation of through an axis, the axis of the rotation. That will also anchor all the, we can anchor all the cylinders. We can anchor this one by grounding. We ground each cylinder, and that takes us to the next. We ground each cylinder, and then if we ground each cylinder, now here every cylinder is grounded, and then we also ground the end. So in that case, if we now decide to rotate, and we select what to rotate as before, we select the in the cylinder number 2, we select the crank, and then we say rotate. It is bodies, now components, selection of crank, and then that number 2. Okay, so the axis of rotation is the axis of this, and then we now put 270. So if we put 270 and we click OK, that rotation is affected. So we apply the rotations that are for each one. The next one is also again 270. We come here, ground this first. So if we ground the cylinder, cylinder ground, and then we choose that rotation again. Create the crank, and the axis is this axis, and the angle again is 270. Okay, so if we ground another cylinder here, and we can just continue grinding the cylinder and then putting the value of rotation and do that all along. Let us so if we do that all along, so grinding everything and then rotating them to their correct we rotate all of them to their correct angular displacements. So rotate everything to the correct angular displacements, and then we can move on until we get to the end. Then the next thing to do is to now make sure that the neighboring cranks are in rigid joints. After the rotation to the correct angles, we now make them to move in rigid joints. So once they're in rigid joints, we can now continue. So once they're in rigid joints, we have all the angles placed and all the joints done. So we can test the final result by going up here and animate the joint. So the joints can be done.